Hello! In this video I'd like to show you how to use the Energy Lab tool and the Seed firmware to optimize power on a video processing application. The use case we're looking at is the Xilinx ZCU TRD reference design, which showcases video capabilities of the Xilinx UltraScale MPSoC on a ZCU106 board. The objective is to minimize power consumption and improve the thermal profile while streaming 1080p video. What you see here is our Energy Lab tool. We have a description of the ZCU106 board loaded. On the right hand side you see the main hierarchy of the description, including all the details of the UltraScale MPSoC, such as the processing subsystem with the full power domain and low power domain, and all of its ARM processors and peripherals and their power states and so on. But we have also modeled the power management details of the FPGA here in the PL section, where we've included the clock scalars and the clock gates that we have inserted in the FPGA design. And then these components are what Seed uses to control the power states of the FPGA components. For that purpose, we've defined scenes, such as this PL scaled scene, which requires a lower clock speed for some of the clocks in the design. Now we will go ahead with the configuration of the Seed firmware. Here we select the optimizations we want. We'll start off with the dynamic preset, which includes various optimizations including frequency scaling, PLL optimization, dynamic idling of peripherals, as well as DDR optimization. Then we will also add the scenes that we created to manage the FPGA. So this allows Seed to access these scenes at runtime. We save that and then go ahead to generation. Here we select the HDF or XSA file for our project, and we let the system generate the ELF file, which is here the seed.elf, which replaces the PMU firmware in our boot.bin. Once we've placed that on our SD card, we can connect to the ZCU106 board and start test and measurement. We see the measured power of the UltraScale Plus plotted on the left and in numeric form on the right. We are just under 2.6 watts for the system being booted into Linux and idle. We will now tell Seed to set the PL scale scene, which we defined earlier, in order to lower the clocks on some of the FPGA components for optimum 1080p streaming. You can see that the PL scale scene has been triggered and the power has been reduced. Now we are ready to start streaming. We open VLC on the host computer and we start the streaming script to process video and stream it over Ethernet on the ZCU106 board. We can see the video streaming in the background, and we also notice the power consumption increasing. We are just under 3 watts streaming 1080p 60 video over Ethernet. To put this into perspective, we will also bring up the standard firmware doing the same thing. As you can see in the upper half of the video, the standard firmware requires more than 4.5 watts to do the same 1080p streaming. This translates to an increase of 54% in power consumption when compared to the Seed firmware. I hope you have enjoyed this video. If you would like to learn more about Agios or about Energy Lab and Seed, please consult our website at agios.com. Thank you for watching.